Here we'll look at another example of solving a linear system of equations where we do have a unique solution to make the equations simultaneously true. So here we're presented with these equations here. We have three unknowns and three equations again, the unknowns being x, y, and z. Now fortunately in this example, the way that the equations are presented to us, we don't have all of our variables on the left-hand side and our constant term on the right-hand side, nor are all of the left-hand sides in the same order, which in this case I'm going to choose that order to be x, then y, and then z. The first thing I want to do is rewrite these equations so that it's in a nice format for picking up what my A matrix is and what my B vector is. So I rewrite these. So on my first equation, I don't want the 5z on the right, I don't want the 3x on the right, so both of those I have to move over, and I have to pay attention to the sign. Because they were positive on the right, they're now negative on the left-hand side. Also, I rewrote it so that I have the x term, then the y term, then the z term. The negative 14 was already on the right, so I just keep it there. For that second equation, I have that negative 2x on the right-hand side, so I have to move that over to the left-hand side. Everything else can remain the same. And for the third equation, my left-hand side was presented as z plus x plus y. I want everything in the same order, x then y then z, so I just have to rewrite that left-hand side so I can easily pick out what the proper coefficients are going to be. So now looking at that right-hand side, the right side of equations, now it's in a nice format where I have x then y then z on the left-hand side and my constant term on the right-hand side. This makes writing my A matrix and my B vector very easy. So my A matrix now, just picking out those coefficients in front of x, y, and z. For the first row, the second row, and the third row, I see I have negative 3, 2, negative 5 from the first equation, 2, negative 6, 4 for the second equation, and 1, 1, 1 for the third equation. And because my coefficients, my constants are on the right-hand side, my B vector is just the right-hand sides, negative 14, 10, and 4. Again, I do want to write down that the x vector is x, y, and z, so make sure that when I get my answer, I know that which number corresponds to which value. Now I can put this into Matlab and get my answer. So my A matrix, I just have to transcribe it. And B, I have to transcribe as well. Again, B must be a column vector for this to work out, so I do want to check that before I try to do any operations with it. Right, my A matrix is correct, it matches what I had on the slide, and my B is a column vector, again matches what was on the slide. So now I can find what must x, y, and z be that will satisfy these three equations. I can use the backslash operator to do this. Right, when I run this, it gives me that unique answer is when x is 3, y is 0, and z is 1 to satisfy this. And we can see that using multiple approaches here, we're going to get that same answer each time. Right, so using the inverse, using that backslash, I get that same answer. And just for demonstration purposes, if I put it into reduced row echelon form, again that same 3, 0, 1 answer is what I get out of that. Again, using any of these three methods is okay, but I'm really going to emphasize that / command since it is going to be the fastest, and when we have unique answers, since all the versions, all the methods give us the same answer, we're going to prefer the fastest one.